KVL for loop number 1. KVL says addition of all the voltage in a loop is equal to 0. So if you look at this one here is 5. So if you are taking clockwise, we have to see if you are taking clockwise what path is going to go through, minus to plus. Minus to plus is positive. So because the current flows from the lowest potential to highest potential. If when you see minus, you know that's the lowest potential, and plus highest potential. So that's the right direction. So that should be a plus. So this is plus right here, plus 5. And then here plus to minus, that is 1k. And we know that Ohm's law, V is equal to I times R. R is 1k ohm resistance, I is I1. So this is, since this is plus to minus, we put a minus for this, minus I1 times 1k. And then if we look at the next one, we have I3 and okay, so here we don't have plus minus. Let's say plus, I just put the sign plus minus for now. Okay, so if it's plus minus, then if we take clockwise, plus to minus is a minus. So this is I3 times 500. Okay, and the next one is, if we take clockwise, this is minus to plus 4k times I4. Minus to plus is positive, so plus I4 times 4k, and that is it. That's equal to 0. That is loop number 1. And if I apply KVL at loop number 2, okay, so here, if you see the longest line, that is, okay, I also forgot the 10 here, 10 in this equation. So this is, longest line is a plus and shortest one is minus. So this is minus to plus, so there should be a plus 10 also here. So plus 10, that's equal to 0. If I look at loop number 2, now if I take the clockwise for the loop number 2, in the loop number 2, this goes from plus to minus, so that's a negative. So here negative 10 right here, and then minus to plus, that's a positive. So 500 times plus 500 times I3, and then 2k. So this is a minus to plus, so that's a positive. So 2k times I2, plus 2k times I2, and then here minus to plus 200, and also plus to minus 20. So if it's plus to minus, that's a minus, so minus 20, and then minus to plus, there's a 200. So 200, the same currents, I2 current is the one following through this everything. So this is going to be I2 as well. So that is 200 times I2, but it's going to be negative I mean positive I2, because minus to plus. Okay, so that is equal to 0. That is KVL at loop number 2. And if I apply, okay, I also missed this one. We have a I5, and that is minus to plus, so that's going to be a plus as well. So this is a plus, minus to, because minus to plus, I5 times 5k, that's equal to 0. So this is KVL at loop number 2. Then if I apply KVL at loop number 3, if I look at loop number 3, if I assume clockwise, then this is plus to minus. So I5 minus I5 times 5k, and then I6 going from here. We don't, let's put plus minus here. So if it's plus to minus, that's a negative. So negative 1.5k times I6. And then here, if we look at this one, so I6 is the same current goes through because it's in series. So I6 and plus 2, since it's going to plus to minus, there's going to be a minus here. And then I6 times 400. And then here we have 4 plus to minus again. 4k times I4, and plus to minus will make it minus. So 4k times I4, and that is it, that is equal to 0. So these are the three KVL equations we can derive from this circuit. And the next one we can do is KCL. So KCL we can apply in each node. So first of all, if I take this node right here, let's say node number 1. So node number 1, at that node, whatever entering we put plus, like the Kirchhoff's current law is addition of all the current entering or exiting a loop is equal to 0. So if I take this node, the current entering is a plus, so I1, and then I2 also entering, so I2 plus I2, and then I3 is exiting, so minus I3, that is equal to 0. And we can look at what other nodes we have, and I can take this node right here and call this, we can call it node number 2. So node 2, okay, maybe I continue with it. Let's use a different color. Node 2, for node 2, if you look at for the node 2, I4 is entering, I5 is entering, and then I3 also entering. So we can say I4 plus I5 plus I3 is equal to 0. You may wonder how this might be possible. It's because one of the current is going to be a negative. Negative mean the direction we assume is wrong. It's going to be negative mean it's going to be opposite direction. So it doesn't matter. Like as long as you put negative, and like let's say you found out I5 to be minus 20 ampere current. So which means the I5 20 ampere current is for going in the other direction because of the minus. But since we mentioned the minus, the direction, if it's minus mentioned, then this is the direction. If it's just 20, it's the opposite direction. So the minus actually replace the direction. So it doesn't matter how do you put it. Like the equation is this. If it's all entering, you just put a plus and forget about anything else. That's it. Okay, and then we can consider this node and this node as well. So if I took a look at this node, like here I1 is exiting, I4 is exiting, and then I6 is entering. So we can say I6 minus I1 and plus I1 plus okay, exiting minus, so I1 also minus I4 is equal to 0. So if I consider this as a node 3, okay, so we can consider this as a node 4. And at the node 4, I5 is exiting, I6 is exiting, I2 is exiting, all of them are exiting. So we say I minus I2 minus I6 minus I5 is equal to 0. And these are the four KCL equations we can derive. Okay, this is for the node 4. So KCL and KVL, once you have all of them, after that it's math. Like now you can find every single current, every single unknown, like current is the only unknown variable here, others are known. So you can find every single current using this formula. You have to just substitute, and after that it's just math. So deriving the formula is a circuit analysis part of this. Okay, and that's it for this video. See you guys on my next video.